Yeah, Pravin, thanks for the introduction and a very good afternoon to everybody. So I thank you for the opportunity that I'm able to share with you a bit about industrial and systems engineering. And so, and so you have seen the video, and essentially, the question that we typically get is, what is industrial and systems engineering? We suffer from the same problem as engineering science. It's very easy for people to understand what's mechanical engineering because you can see the buses on the road. It's very easy for people to understand civil engineering because you can see all the structures that we are staying in. So what is industrial and systems engineering? So in a nutshell, essentially what we are interested in is that we are interested in solving problems or looking at how we can improve the way that we are doing things. And so how we do that is via a four-step approach, which we have highlighted in the video. In particular, first, you need to have a good understanding of the problem that you are tackling. And next, we want to then come up with various solutions to look at how we can implement them within our current system. And given the various real world constraints, we then look at what is going to be the best out of these solutions out there. And finally, we need to make the decision, not just based on the gains, but we also need to consider the risk that are going to be involved as well. And so given that these are the things that industrial and systems engineering is going to be doing, then these are essentially the topics that industrial and systems engineer needs to be equipped with. So as mentioned, you need to be able to analyze the problem at hand. And so that's where data analytics is going to be very important. And so if you were to ask me, how do I know if I'm going to make a good industrial and systems engineer? I think the first question over here is, are you good with numbers? So you need to be good with numbers. And at the same time, you need to be interested in looking at historical data to try to make sense of what is going on over there. One tool that industrial and systems engineers have a lot, which the industry likes a lot, is going to be simulation. And so if you look on the right over here, this essentially it's a simulation of a warehouse. And so why is simulation so important? And so by simulation, what we are doing is that we have a digital model of what is actually happening out there in the factory or what is happening in our real life problem over there. And so once we have a digital model, we are then able to test out different types of solutions. So for example, I could ask the question, if I was to put in the budget to buy 10 more forklifts, how much is it going to reduce the turnover time for the order goods over there? Or for example, if I was to relocate my shelves from this area to this area over here, how much is it going to increase my performance? And so the ability to have the simulation tool over here allows us not only to analyze the problem at hand, but it gives us the tools to actually look for the best solution. And so that's what industrial engineering is all about. We are looking at how we can actually improve things over here. And so the other topics are optimization, systems thinking, and all these are going to be very relevant as well. I think one thing that I want to talk a bit more about is also going to be systems thinking, because essentially when we actually make a change to, let's say, the workstation over here, it's not just going to only have an impact on this area, but it's also going to have an impact on other parts of that system as well. And so this idea of systems thinking is something that is recognized by the industries out there. And so they need people who know how to look at the problem not just at the local level, but across a systems level. And so that's where we train our graduates to think in terms of not just in terms of what does this do, but in terms of how does what I do over here cascade to the other parts of my system over there. And so systems engineering, systems thinking by itself is going to be one broad topic that our graduates will actually go through. Okay, and so the best way to kind of understand what industrial and systems engineering is to look at the projects that our students have done. And so over here, we have a QR code. Feel free to just go to our website over here. And so over here, we have 6 projects that our students have done with various companies over there. And so one key highlight of our program that I think we wish to share with you is that all our students would go through a 2-semester project where they will work in a group. They will be attached to a company, and they will talk to the company to understand the problem. And so they are going to work very closely with a company representative. And so the company representative will work with them to understand the problem. And this will require our students, to go down to the company to talk to the various stakeholders. They will talk to the people on the ground. They will talk to the managers to understand the problem and understand the various constraints. And then next, they are going to develop practical solutions, and then they will go ahead to implement the change. And one key important step over here is that then they would quantify the improvements over there. So this is very important because by the end of the project, our students would then report to the company. So for their final presentation, they will say that we have worked on this problem, this was the problem, this was our recommendation, and following our recommendation, the company was able to achieve an annual savings of this amount of money over there. So straight away, the value proposition that this team has brought to the company is very clear. Okay, and so this is why our graduates something we ask our graduates to focus on, because at the end of the day, when you have something like that on your CV, it greatly enhances your employability. So this slide over here essentially are just our industry partners. And so for our systems design project, we've worked with a lot of companies. We've worked with companies who are in the manufacturing industry. We've worked with companies in healthcare, so Airbus Manufacturing, Health Alexandria Healthcare. We've worked with the banks. We've also worked with accounting firms and a whole host of industry. So it's not just one particular industry, but industrial and systems engineering actually applies across a wide variety of sectors. Curriculum highlights, like most programs in NUS, we do offer a lot of opportunities to our students. So a quick survey with our students, around half of ISE students actually have at least one overseas study abroad experience by the time they graduate over there. And at the same time, we have made our curriculum a lot more flexible, such that students can go ahead to design the various types of modules that they want to take. And so these days, it's going to be very easy for students who are interested in going for a minor, a double degree, to actually go about achieving this over there. Okay, so we have a significant amount of flexibility in terms of our curriculum for this. The type of minors and um, majors that are going to complement the IC skill set well are things like artificial intelligence, computer science, and so on. So these are the popular ones among our undergraduates. So in the interest of time, I'm just going to move forward. But as mentioned, we're going to be putting this video online, and all the questions, feel free to just check with us if you have any questions regarding this. Okay, and so just now I've mentioned that our graduates have good career prospects, right? Because they demonstrate the value that they bring to the organizations. So let me just now bring you some numbers. Like I say, you have to appreciate numbers, right? If you want to be a good industrial and systems engineer. So our career prospects are pretty good. If you look at it, you typically, if you look at the newspaper these days, they're reporting the full-time employment, and they're also reporting the median salary. And so in terms of full-time employment, 93% of our students secured full-time employment. And then the median salary out of these students who obtained full-time employment was actually 4,380. But being an industrial engineer over here, you kind of got to appreciate that if you present this information to your stakeholders, you present this in a boardroom, it's going to be a whole mess of numbers. How do people kind of make sense of this over there? Okay, and so being an industrial engineer, this is what we would typically do. Since there are two dimensions that we're interested in, we plot this on a two-dimensional plot. So each dot over here, essentially, is a degree program, either by NUS, NTU, SMU, or SU, SS over there. And so on the x-axis is essentially their full-time employment rate. On the y-axis over here is going to be the median salary. And so I hope you can see from here, essentially, you want to be at the top right corner, right? You want to ideally have a program where the employment rate is high and the salary is going to be high as well. And so this is where ISE is going to be. In particular, I wish to highlight that the 75th percentile for salary is 4,000, and the 75th percentile for employment rate is 86.9% over here. And essentially, there are only 12 degree programs out of these 4 universities that actually exceed both of these benchmarks over there. Okay, and so you have your regular suspects. Medicine is here, computing is there, and dental is with medicine, law is there as well. But that's where industrial and systems engineering is among one of these 12 programs over here that actually exceed both the 75th percentile for median salary and also full-time employment rate. Okay, and so that's what industrial and systems engineers do. We don't just kind of say that, hey, this looks like a good idea. It looks like a good choice to come into industrial systems engineering. or that, oh, we have good career prospects. This is where we need to supply the data to go about to facilitate the decision making over there. And so it's not just a matter of having the data, but it's also a matter of how do you go about to present the data? How do you go about to infer the data that is going to be important as well? Okay, and so a further note on the career prospects over here is that we wish to say that 2020 was a very challenging year. I'm sure that everybody recognizes that 2020 was a very challenging year over here. But in terms of our employment, we have actually done pretty well. Overall, the employment rate for the nation actually dropped by 14.6%, whereas for industrial systems engineer, we only dropped by about 3.6% over there. Okay, and so the question is, why is that so? And it is simply because our graduates actually find employment across a wide range of industries. So manufacturing, supply chain are the typical ones, but you see a lot of our graduates in business, digital technology, and also government and services as well. Okay, so due to interest of time, I wouldn't be able to share too much, but ISE is going to be very well positioned for the digital economy as well. Okay, and so if you're interested, feel free to check out our website. All the information is actually over there on our open house website. Okay, I just want to highlight our trade minister who has mentioned that in a post-COVID world, having a more diversified economy is going to be very important for us. And so that is where when you look at ISE, what we give you is a useful set of analytical computing, managerial skills applied across multiple industries. And what is the result over there? Our graduates are able to seek out the best paying jobs. Our graduates are resilient against industry-specific shocks over there, as I've demonstrated to you. Although 2020 was a challenging year, our graduates were still finding jobs out there because they have a set of skills that are versatile across a wide range of industry. The last thing, which I think it's not emphasized too much, is that you are able to find jobs in an industry that you are interested in, which I think is important because it's only when you're in an industry that you're interested in, then only are you able to give off your very best. So very quickly, just to highlight this point about interest, I have my project over here. So this was one of the systems design project. It was with Infineon. So this was with a manufacturing company over there. So they did their project. They identified the problem. They built the simulation. They made the recommendations to the companies over there. The companies loved the job. Loved the project over there. But one of the teammates over here, Henry. So Henry was actually featured in Channel News Asia back in 2019. And in the end, he didn't went on to work in the manufacturing industry, but he went on to work in a tech startup over there. So Henry was one example over here, where given a versatile skill set, you are able to go into whatever industry you are interested in. Okay, and finally, I guess the question that I want to answer over here. So let's say I've convinced you that industrial systems engineering, it's interesting. You want to find out more. So why do it at NUS? And this is where I would say it is because of our brand name. NUS has been around for over 100 years. Our department has been around since 1969 over there. So our brand name is there. Our connections with the industry, our connections with the partner universities is something that none of our competitors out there can actually match over here. So if you think about your studies over here, industrial experience is going to be very important because this is where you are going to highlight in your CV that I have worked with this company. I have achieved this cost savings to the company over there. And so if you look at our systems design project, I've highlighted to you that we work with a wide range of companies. Same thing for internship as well. Because of the NUS brand name, we are going to have a lot of companies that we can offer to you. Same thing for your study abroad experience as well. We have a wide range of exchange programs and also that you can also consider. Okay, and so I probably have shared um, more than the time I've been allocated. And so I really want to spend some time to allow my panelists to answer the questions as well. So, but this is our website over here. And so feel free to just click on this QR code over here, scan this QR code, go to our website, and a lot of the information is over there. And in case some of your questions are not answered, feel free to just drop us a post on Facebook. We will reply on Facebook. Alternatively, if you want to talk to our students, you can drop you can direct message them on their Instagram page. In fact, I don't get a lot of questions on Facebook, but my student club is telling me that they are kind of getting, they are overwhelmed with questions via the direct message. So I think that that seems to be the preferred channel by you guys over there. Okay, and so feel free to just relay those questions to us. Okay, and so let me very quickly now switch gears so that we can go over to our Q&A section over here. Okay,
Yes,
but
we have highlighted a few questions at the back end to be that came in. You can go through them. Yeah.
oh yes, thanks, Pravin. Okay, and so for my Q&A session, we're very happy that we have Prof. Ng. So Prof. Ng is our acting head of department, so she's with us today. At the same time, our deputy head in charge of our undergraduate affairs, Prof. Chu, is also with us as well. And we have two students with us. Elle, who was actually our vice president for our student club last year, and she's currently a third year student. And also we have Kerwin, who is currently the president of our student club over there. So let me just run through the questions over here, and let me just quickly pose the questions to our panelists. And so for the first question, let me just direct it to Prof. Ng over here. And so we have a question over here which asks, are ISE graduates in demand? And so Prof. Ng, can I hand the mic over to you to take this question?
Sure. Thanks, Chin Hon. Maybe I can answer this in relation to also another question that came up that asked how different ISE is from data science and analytics. So I think our program overlaps in terms of some of the foundational principles with data science and analytics, like the fundamentals of statistics, math, and so on. But we are also unique, particularly in the sense of training our students to have this systems view and systems perspective. So our curriculum, as you highlighted, is founded pretty much fundamentally in our modeling, analytics, computing skills. With that is also a very strong systems perspective and view, which we train our students with both theory and hands-on experience, so that they can look at problems from a holistic, systematic systems view, and then work together with other engineers and other stakeholders to solve these complex problems in a holistic manner. So from end to end. So that's pretty much very unique to our students. And that leads me to the next question on whether ISE graduates are in demand. So again, as Chin Hon has highlighted, our students are very much in demand. If we just look at the employment survey, that clearly tells us so. Firstly, our employment rate is very high, continuously for many years. And in the last few years, we are still, in the 90% over. And as it shows also that, during this difficult period, we are still highly in demand. And because our discipline or our field is actually extremely flexible, our students are versatile. We're not specifically domain specific. So if specific domains or economic situations are difficult, our students are flexible and can move to other industries that are in demand. And the other very clear indicator is our salary survey. Continuously over the past years, our students' salary, graduate salary, has been increasing. And even in the past year, we have increased much higher than the overall increase for all the graduates. So this clearly indicates our students are in demand. And I think the key is, as you highlighted, the flexibility of our students, because we train them in a core skills, fundamental skills, and not that's applicable across many domains. And because of that, they're very resilient to economic shocks and changes in the economy.
Thanks, Su Hui, for the response. And so next, we have another question regarding our curriculum over here. And in fact, In fact, we have, let me see, there are two which I think is kind of related to the curriculum. So let me address them to Prof. Chu over here. So the first one is that, is there a lot of physics and math in our course compared to the other engineering course? And the second question that we have over here is, would I be able to just decide on my major or minor at a later point in during my course over there? So for these two questions, let me hand it over to Prof. Chu. Prof. Chu, pass the mic over to you.
Okay, thank you very much, Ching Hong. So to answer the first question about whether there's a lot of physics and mathematics in our ISE curriculum. So for your information, actually physics is not actually the area that the industrial systems engineering is concentrating on, but rather actually in terms of mathematics will be the main core of our fundamentals. But while saying that mathematics are main core, essentially the two mathematics that you are actually going to learn is actually the common mathematics modules which all engineering students will undergo if you take engineering. But besides that, right, the rest is actually what we are saying, some modeling skills that we are trying to equip you. So essentially trying to apply mathematics into solving problems where we will actually equip you with what I call modeling a problem. For example, if you see a problem that you want to solve, and so are you able to actually transform this problem into some models which uses some mathematics to be able to help you to understand the system behavior and the interaction between subsystems? Because as you know, today's problems are more complex than what was in the past. And so having to try to use your intuition to get what is the issue or what is the decision that you make will impact the overall system will not be so simple. So you need to develop models. Like for example, Ching Hong have just now shared with you one of the models that we actually teach a student to do is a simulation and modeling skills, where you can develop a simulation model to actually help you to actually understand the system's behavior of the system behavior of the system, and then from there you'll be able to evaluate what is the outcome if certain processes change or certain decision that you want to make. So how will you actually affect the solution? So the other question that you also want to ask is about the major and minor. So essentially, if you look into the structure of curriculum, what we do is that usually in the first year, you do a very what you call common courses where many other of your engineering discipline will also do the same. And so after that, when you progresses later on to another stage, right, this is where you start doing your major, which is a single major. And then it's only in the later part of the years, maybe in the stage 3 or stage 4, this is where you can start thinking about doing double major. You can also do specializations or minor, or you can do some other modules that you do not want to actually look into minors, but not any modules that you want to take, you know. So you have this kind of choices. So you start off with a common module where a lot of students will take as a common level. Then when it progresses to second, third year, fourth year, then you start concentrating on your single major. And then after followed by, if you decide to do a second major, you can decide to do that. Or if you want to go and deepen your knowledge into ISC, you can take some specializations that we are trying to propose, or you can do a minor as well and a specialization. So there is a lot of choices for you to take.
Yeah, thanks, Prof. Chu, for the elaboration on our program and also on the major and minor. So I look at I'm sensitive towards the time. I'm sure Pravin is going to kick me out very soon. And so I still have two more students, like I mentioned, our year 3 and year 2 student, Elle and Kerwin. So very quickly, let me just hand the mic over to them, and they are going to, and so we can hear from them about what student life as an INC student is, or the daily life of the INC student. So let them, so Elle, I hand it over to you.
Hi, thank you, Dr. Tan. So I saw a question about IC student lifestyle. So for me, a lot of my days were spent in school doing projects because most of the ISE modules contain group projects where you have to use the software provided in the computer labs in school. I mean, other than the academic portion of the student life, we also can take part in many student activities that are organized by the IC Club. So I would like to ask Kerwin to share more about these ISC Club activities. Kerwin, are you here?
Yeah, okay, thank you,
Okay.
Elle. So for the ISC Club, right, we have various activities ranging from night cycling. So we have activities that provides cohesion amongst the ISC students. Then we also provide various welfare, like we have welfare day, where we actually give out like bubble tea. Then we also provide like goodie bags to actually help to motivate students to in their studies, like when exams are nearing. Yeah, so we have activities that helps to build bonds within the ISC students ranging from year ones to year fours. And yeah, that is more or less about ISC Club. And I'll pass it over to Prof. Tan.